Now we're going to talk about adding rational expressions with different denominators that have multivariables. We need to simplify our answer. First, we need to look at our two denominators. We have 2a to the third d to the third and 8a k squared. Our common denominator between a 2 and an 8 is going to be an 8 because 2 will go into 8 and so will 8. I have 3 a's and 1 a, so I need 3 a's at minimum. I have 3 d's. And 2 k's. So these are going to be my common denominators. Now, in order to turn 2a to the third d to the third into 8a to the third d to the third k squared, I'm going to need to multiply this denominator by 4k squared. If I multiply the denominator by 4k squared, I also need to multiply my numerator by 4k squared. So that's going to give me a new numerator of 12k squared y. I also need to turn this denominator into 8, a to the third, d to the third, k squared. Now I already have 1a, and I already have an 8, so I'm going to need to multiply by a squared. I have my k squared, but I need d to the third. So I'm going to also multiply my numerator by a squared d to the third, which will give me a squared d to the fifth w squared. Now I can add these together. So I have 12k squared y plus a squared d to the fifth w squared over 8a to the third d to the third k squared. Now, as we compare each of these three terms, no term has anything in common with all three. So there's nothing I can do to reduce this, and I am finished with this problem. Let's try one more. I have 12b to the third d squared and 9b squared k squared. So my common denominator between a 12 and a 9 is going to be 36. That's the smallest number that 12 and 9 both will divide into evenly. I have 3 b's and 2 b's, so I need 3 b's in my common denominator. 2 d's and no d's, so I'll need 2 d's and 2 k's. Now, in order to turn this denominator into 36b to the third d squared k squared, I'm going to need to multiply by 3k squared. So I'll also multiply my numerator by 3k squared, which will now give me 3k squared x. To turn this denominator into our common denominator, I have to multiply the 9 by 4. I have 1 b, so I need one more b. I don't have any d's, so I'll add those. And then I do have the k squared. So I'll multiply the numerator by the same, which will give me 20 d to the third b w squared. I will now add my fractions together, so I get 3k squared x plus 20 d to the third b w squared, and that is all over 36 b to the third d squared k squared. Now again, I'm going to compare each of my terms and see if there is anything that all three of them have in common. And as you can see, 3, 36, and 20 can't reduce, and none of the variables are in all three terms, so this one is also complete. Now we have rational expressions that have different denominators, but they're in the form of expressions. So what we need to do is we need to find our common denominator between x and x plus 2. Well, the common denominator between x and x plus 2 is x times x plus 2. Which means I have to multiply this denominator by x, so I multiply my numerator by x, and I have to multiply this denominator times x plus 2, so I'm also going to multiply my numerator times x plus 2. So this gives me a numerator of 2x, and then I'm going to come over to the side here in order to FOIL this numerator. So I first, outside, inside, and last, which gives me negative 2x squared minus 2x plus 4. Sorry if you can hear my child in the background. He's playing video games. Okay, now I can add my two fractions together because they have a common denominator. Now I do have some like terms here. I have 2x and negative 2x. Those are going to cancel each other out. And so I have negative 2x squared plus 4 over x times x plus 2. If I factor out a negative 2 here, or even a positive 2, I can get negative 2 times x squared minus 2 over x times x plus 2. Now it's completely factored and completely simplified because nothing will cancel, and this is our final answer. Let's try another one of these. I have an x minus 1 and an x, so my common denominator is going to be x times x minus 1. Which means I will multiply this denominator times x, and so I'll multiply my numerator times x, and this denominator times x minus 1, so the same here. This will give me a numerator in my first fraction of 4x. Again, I'm going to come over here to the side to FOIL out my new numerator for the second fraction. So I get 2x minus 2 minus 2x squared plus 2x, which gives me negative 2x squared plus 4x minus 2. So this will be my second numerator. Now when I combine these, this time I have subtraction. So I'm just going to keep writing this out. And I'm going to put that second numerator in parentheses so that I don't forget that I have to distribute this negative. And what that does is, if by distributing the negative, I change my problem to addition, and I change all of my signs. So my negatives become positives, and my positives become negatives. Now I have Oops, that's supposed to have 2. Now I'll have 2x squared. I have 4x minus 4x, so that goes away, plus 2 over x times x minus 1. If I factor my numerator, I get 2 times x squared plus 1 over x times x minus 1. And again, nothing here will cancel, so that is my final answer. Here we have quadratic denominators. When you see quadratics in the denominator, the first thing you need to do is you need to factor these quadratics. So to factor these quadratics, I'm going to use the method that will involve factoring by grouping. So I'm going to multiply 5 times -1, which will give me -6. And I'm looking for factors of 6 that have a difference of 4. So I'm looking for factors of 6 with a different. Well, as you can see, I apparently can't multiply today. 5 times -1 is not now, nor has it ever been, -6. 5 times -1 is -5, which makes the impossible problem I was just staring at that much simpler. I'm looking for factors of -5 that will give me a -4. If I multiply -5 times +1, I get -5, and if I add them, I get -4. Now I'm going to rewrite this as 5x squared minus 5x plus x minus 1. And the reason I did this is because this right here will replace the -4, and now I can factor by grouping. From 5x squared and 5x, I can take out a 5x, which leaves me with x minus 1. And from x minus 1, I can factor out a 1, which leaves me with x minus 1. So this denominator will factor to 5x plus 1 times x minus 1. For my next problem, or for my next fraction, I do 5 times 1, which gives me 5, not 6. And I'm looking for factors of 5 that will add up to 6. Well, that would give me 5 and 1. So I'm going to do 5x squared plus 5x plus x plus 1. This will factor out of 5x to leave me x plus 1. And from my second, I can factor out a 1. So I factor to 5x plus 1 times x plus 1. So now I'm going to go ahead and rewrite these as 6 over 5x plus 1 times x minus 1 plus 4 over 5x plus 1 times x plus 1. Now, as you can see, both of these fractions have 5x plus 1 in common. So in order to give these a common denominator, I only have to deal with this x minus 1 and this x plus 1. So I'm going to multiply this times x plus 1 and this times x plus 1. And I'm going to multiply this times x minus 1 and this times x minus 1. This will give me 6x plus 6 over 5x plus 1 times x minus 1 times x plus 1 plus 4x minus 4 over 5x plus 1 times x plus 1 times x minus 1. If I combine these, I can add my like terms. 6x and 4x is 10x. 6 minus 4 is 2. All over 5x plus 1 times x plus 1 times x minus 1. As you can see, I've run out of a little bit of room here because I still need to factor my numerator. So what I'm going to do is, through the magic of film editing, I'm going to fix that situation. Ta-da! Okay, now I'm going to factor a 2 out of my numerator, and I'm left with 5x plus 1 over 5x plus 1 times x minus 1 times x plus 1. And as you can see, I have two terms that will cancel each other out. And so my final answer is 2 over x minus 1 times x plus 1. Okay, one more example of these. I'm going to try to write a little smaller this time. I have 4 times negative 9, and that's going to give me negative 36. And so now I'm looking for factors of 36 that have a difference of 9. Factors of 36 include 1 and 36, 2 and 18, 3 and 12, and 3 and 12 have a difference of 9. Now I want that to be positive, so I'm going to use positive 12 and negative 3. So I'm going to use that, and I'll get 4x squared plus 12x minus 3x minus 9. I can factor 4x out of my first two terms to get x plus 3. And I can factor a negative 3 out of my second to get x plus 3. So this will factor to 4x minus, lost my pen, minus 3 times x plus 3. Now for this denominator, I have 4 times 6, which is 24. And I'm looking for factors of 24 that will add up to 11. Now 4 and 6 are factors of 24, but they add up to 10. I have 2 and 12, or 8 and 3, and I want them to be negative, so I get a sum of negative 11. So that gives me 4x squared minus 8x minus 3x plus 6. From my first two terms, I can factor out a 4x, and that gives me x minus 2. And from my second two terms, I can factor out a negative 3, which gives me x minus 2. So this will factor as 4x minus 3 times x minus 2. Now, rewrite these with my new numerators. And as you can see, they have a 4x minus 3 in common. So I need to multiply this one by x minus 2 in the numerator and the denominator, and this by x plus 3 in the numerator and the denominator. Now for the sake of space, when I distribute this, I'm going to get 9x minus 18, and that's going to be plus 3x plus 9 all over 4x minus 3 times x minus 2 times x plus 3. Collecting my like terms, I get 12x minus 9 over 4x minus 3 times x minus 2 times x plus 3. I can factor a 3 out of my numerator. And as you can see already, I have two terms that are going to cancel. So I will cancel my 4x minus 3 and my 4x minus 3. And my final answer is 3 over x minus 2 times x plus 3. And that is adding rational expression with various forms of different denominators. Hope you